afternoon. Advancing the spatio-temporal mapping of mathematical cognition from a traditional squid MEG to the OPM MEG. Okay.
Maybe battery, I don't know.
It's good time.
Yes, battery, and
Okay.
not working, but I don't know.
The goal of our research was to prove that there is concept of the number in the brain. We used MEG scanner for this goal. Now let's see why MEG is the best choice. We want to compare MEG with fMRI and MEG with EEG is the famous scanner in the researchers. Okay, MEG versus fMRI. Why MEG and not fMRI? Traditionally, brain scientists used fMRI, which measures the change in blood oxygen level. However, fMRI has a huge downside. It has a delay of several seconds. Since cognitive math process happened in milliseconds, fMRI is simply too slow. Okay. Here in this image shows how MEG is more accurate than fMRI. Here we see a fMRI scan. We see the MEG scan. This very concept here is an all the brain, not accurate the fMRI. Okay. Now, why MEG and not EEG? We compare by MEG with EEG. Here, the MEG, the new MEG we talk about. Just here is a EEG. To avoid indirect measures like blood flow, researchers prefer to measure electrical activity directly. However, its main disadvantage is low spatial resolution. It tells us exactly when brain activity happens, but not exactly where, the EEG. EEG measure electrical fields and potentials. Characteristics is capture the electrical activity of the brain, but the signals are often altered or smeared or they pass through intervening surface like skull and scalp. But in MEG, we return to our experiment. In MEG scan, we measure a magnetic field, not electrical field, but magnetic field that comes from an electrical field. That electrical field is created by movement of sodium and potassium ions on both sides of the nerve cell. This movement, just a minute. This movement happens because of a difference of in electrical potential. It creates electrical field, which then produce the magnetic field that we measure with the MEG. Here we have a lot of K plus go out the channel with the channel out the side, and here we have a NA plus enter to the cell. MEG technology is especially effective at measuring the activity of nerve cells that are parallel to the scalp. Since the magnetic field surrounds the electrical current, this angle allows the magnetic field to exit the scalp in the best way possible, leading to a stronger and clearer measurement. Here we saw the MEG. This is the MEG sensor array. Here, axon in the cortical surface on the brain, and when the ions of potassium and sodium go to the axon, direction of electrical current in active axon, squeeze sensor detected magnetic field of current. Okay, moreover, a MEG scan can outperforms a regular EEG, as a MEG scan can detect a brain activity source that a regular EEG miss entirely. There are two main reasons for this. Require a smaller active area to capture a clear signal. A MEG scan requires synchronized activity as much smaller brain area compared to an EEG. This makes it highly sensitive to localized brain activity. See deep into brain fissures. MEG is much better identify source in deep area. This means it can easily detect signals hidden deep inside brain faults and fissures like lateral sulcus and insula is a deep brain, and the operculum in the deep here. Here we see how the MEG can measure a little bit of magnetic field in hidden sulcus, like this. Okay, in our study, we analyzed the brain recording to understand cognitive procedure related to mathematical precision. We map brain magnetic field using MEG scan while participants answer questions. Participants submit their response by pressing buttons on a MEG detector. We want to understand how a human brain perceives numbers. Specifically, we want to learn about the cognitive mechanism behind seeing number in different forms. To test this, we showed our participant numbers presented in various visual shapes. By changing the visual representation, we can see how the brain reacts to the exact same numerical value. For example, the question that participants were asked, which number do you recognize on the screen? Every time we showed a participant numbers in different appearance.
So what did they respond by saying or by pressing a button?
By pressing a button. Now we want to compare old MEG with a new MEG. Now that we have established advantage of the MEG system, other alternative neuroimaging tools, we want to present the historical development of this remarkable instrument. Squid MEG is the old MEG, called Squid MEG, and OPM MEG are two different technologies used measure the tiny magnetic field produced by the brain. Squid is the traditional old method, while OPM is the newer or the next generation technology. Here, we show the Squid MEG, and here, this is me now, the new OPM MEG. In this picture, we see two generation MEG machine. Yeah. All the participants with the new MEG are happy. Okay, and the old MEG, this is old MEG. Sensor and architectures configuration. Sensors, it have 200 to 300 fixed sensors. But the sensor, one sensor's primary signal axis, scalp distance, this is far from the scalp, 1 to 3 centimeter away from the brain due the required vacuum insulation gap. Speed and signal properties, temporal resolution, sub 1 millisecond, samples rate, typically operation 1 to 5 kilohertz, frequency band wide, extremely wide, spinning from DC above 1 kilohertz, and power, voltage, and infrastructure requirement. Operation temperature is 4 Kelvin, like minus 269 Celsius degrees, using continuous liquid helium bath. Voltage infrastructure, demand 3-phase power line. Total power, it's 15 kilowatt. Participant preparation, this. We have a very problem or very work to do our experiment, attaching sensors. We glide sensors into 5 specific points around the participant head, and only then could the experiment begin in this 1 and these 2, 3, 4, and 5. With this stylus, we went over the whole scalp to map the head in 3D space, which poses a problem for subjects with a long hair. Pros for this Squid MEG, it is a well-tested technology that doctors and scientists have used successfully for decades. It measures the whole brain at once using a built-in helmet with other 300 sensors. Cons, it's very expensive. We used liquid helium, very costly and difficult to maintain. No movement. If the patient moves even a little bit, it ruins the quality of the skin. To run an experiment with the old MEG system, Squid MEG, we had to prepare the participant half an hour in advance in minimum. With the old system, we faced a major bottleneck. There was no real-time feedback. We could only check if the scan was successful at a very end. If the participant moved even a little bit, the data was run because we couldn't know in this real time. we often had to repeat the entire experiment, which caused a lot of discomfort for the participant.
Why? Why was there no green?
Because the MEG machine and the معرفة تفعلها شنو؟
You couldn't see the screen when you were doing
Precious.
that was outside of the room.
we want to compare the beginning and the end of the experiment to compare if the patient move or no. The old device was very large and took up an entire room, so I had to convince people that it was harmful and that there was no dangerous radiation coming from it. In contrast, the new device is very small and fits directly on the head. We talk about it, making it look much more user-friendly. Now, if we want to talk new MEG, it's that little sensors architecture and configuration. Sensor, it have 16 to 128 sensors, but one of sensors frequency dual axis or triaxial, measuring 2 to 3 vectors component per physical sensor. In our new device, we have 128 sensors. It's equivalent to 384 sensors at the old device.
That means that you have a 3-point measurement of what particular color, right?
Like other units, you're asking the same sense of have like three particular axes?
Now this reads to me
Yeah,
measuring 2 to 3 vector components per 50%.
yeah.
What does this mean?
One sensor in a new MEG, one sensor have three can measure 3D, 3 direction, but in the old have one direction, not 3.
What is the new technology that I don't want to quit?
No, after. Okay. Temporal resolution sub 1 millisecond. Typically, sampling rate typically operates 1 kilo to 2 kilohertz. Okay, this is work with DC 150 to 300 hertz. This is operate temperature, operate without liquid helium. This work with the room temperature. Plug and play architecture operating. This is 110 volt or to 220 volt, 50 at 60 hertz, like wash machine. It's not three phase like the old machine. Okay, total power consumption 2.7 kilowatt. It's 80% a lot above of rejection in the old machine.
So what kind of sensor?
What?
Kind of sensor?
Yeah, yes, yeah. Okay, because the sensor touch the head, they can detect deep or weak brain signals that squid miss. Allows movement, great for scanning young children who cannot sit still. People with movement disorder like Parkinson or epilepsy patient. It's nice for this patient. Okay, no helium needs, saves money because it does need expensive cooling liquid. Super sensitive to outside cones. It's super sensitive to outside noise, moving the head inside even tiny magnetic field like the Earth's natural magnetism can disrupt the sensors. It requires highly advanced shielded room to work properly. Still new, the technology is still developing, being tested around the world, so it is not yet standardized at the older system. No FDA approval yet. Can only be used for research. We can use it for clinical.
What is statistics? Yeah, what are the sensors?
Just minute. No, I have. Just minute. Okay. Okay, just a minute. Okay, moving away extreme freezing temperature, it change everything about how we can scan brain. The old way in the squid requires expensive liquid helium to freeze sensor. The machine massive and stationary. The new way eliminate cryocooling entirely sensor operate at room temperature. The result, the technology shrinks from the size of a room sensor, the size of Lego bricks, drastically reducing operational costs. The psychology, okay, the massive size intimidated participant require explanation to prove it was harmless. In the new device, the user-friendly shift, the small head-mounted design look familiar and eliminates patient hesitation. Okay, closer to the brain by removing thick thermal insulation. OPM sensor sit directly on the scalp, capturing signals up to the five times stronger with higher spatial resolution. Wearable freedom, participants no longer need to sit as still as statue. The lightweight wearable hand allows for natural movement and interaction during cognitive tasks. Inclusive design, unlike rigid one-size-fits-all system, OPM array can be adapted to any head size, making high fidelity scanning possible for infants and children. Okay, the psychological barrier, the massive size often intimidated participant, requiring explanation to approve. Here, picture with free moving. The user-friendly shift, the small and head-mounted design looks familiar and eliminates patient hesitation. Now is your question. In the squid cortex, in the squid MEG, we have a superconductor quantum interference device. In the new MEG, we have optically pumped magnetometer. Cooling, extreme cryocooling with liquid helium, operate at room temperature. Distance to brain, sensor sit 2 at 3 centimeter away of the scalp. Sensors placed directly on the scalp. Okay, this sensor we can put and we touch the scalp. This sensor, all the sensors is free moving. Okay.
So I think what it is that the This is what is measured.
I think it's more like you use lasers to, like, this laser cooling.
Yeah.
So you have atoms that you make them all point in the same direction with lasers, and then they are extremely sensitive. Sorry.
What you said.
I misunderstood.
That's what I meant.
Yeah.
Sometimes
Okay. Okay, the transition from squid MEG to OPM MEG is like to moving from the old landline telephone to modern smartphone. But let you make calls, but smartphone gives your clarity, power, and most importantly, true freedom of movement. Okay. Thank you.
it's more sensitive.
More sensitive, yeah. Yeah, more sensitive.
First of all, yes. We can survive. Practically, the fact that there is no FDA means that we used to have 1 day a week clinical bringing and paying for that. So that 1 day clinical subsidized the entire research. Now we don't have it because of the no FDA. So it's very expensive for us. We need a lot of grants, etc. to cover it.
How much does subtraction machine cost?
I think the original was 4 million or maybe it's 3 million. But it costs a lot in the room, the children's room.
But still, it's a revolution, right?
It's a solution. They have to accept.
So now
They
everybody
have to
can do this.
accept because even though they pay for it, the clinical, if you have to tell you all the time, it's not so easy sometimes to get.
Yeah, it's in short supply right now.
Yeah, and I knew from the time I was vice president in the PCC and other things, always wanted something that they can pay you by themselves. I don't know how to call it.
So the real obstacle right now is the shielded room.
Yeah, we have a shielded room, we use the same shielded room that we adapted. The old shielded room existed, and you just have to be a little bit adapted. But the free movement makes a big difference. It's very, very sensitive. Before a student to bring a student and after 20 minutes, especially if you move the little bit, and now you go out, you look at that, you see movement,
Yeah.
you bring it back for another 20 minutes, you got crazy.
Mhm.
And the kids got crazy. Now it's much easier, especially with children. We didn't tell you, anything about our work on mathematical education, but we bring high school students. And it's okay for students. No FDA is not a big deal. Ethical department of the university allows it.
Oh, now I see you cannot have screens in the room because of the shield.
Yes.
Because the screens produce their own activity.
So the screen, they see the question, let's say the steward, they see the question, but the computer itself is very far away.
Yeah.
And there are series of mirrors that is bring finally the picture to the screen. And of course, he needs to click. This is also create some. And this is
And the most different of this, we can now to scanning MEG with the patient writing. We can't before. We have a lot of choice for experiments.
they skin out the effect of moving the hand.
So that comes out of the device of patents, right?
No, it's you get this description of pixels.
Yeah, but how? What is the carrier information? What goes through the cables that connect the OPM device?
Cables.
It's quite okay.
Yeah.
But I don't think it's a laser inside. Not the right laser. No. It's a code, but
But what's the difference?
We can measure the delay. We can measure the delay times with the when we show and when the participant put in. Regular, yeah, regular couple. Yeah.
Generate magnetic wonder.
Okay. How I get somehow the both over.
But if it were optical cable, then I would get it.
I don't think it is, but maybe also it's very close to the border of the shelter, so it comes out.
Yeah, let's kill it. I don't know the magnitude of the magnetic field. but we have-
Maybe that is calculated, maybe that is normalized. I should.
Yeah, and then maybe that they get something else, or whatever.
Like this, we have cables, but it's built in with the room shielded. Mhm. This look, this is cable. Yeah, this is cable. This is the regular cable. Yeah.
Somehow it
No,
doesn't.
because the wire is very far away from the sensor itself.
But anyway,
The decay of the magnetic field is way stronger than the electric field. So if it is distant enough from the sensor, then you don't get the direct.
Yeah, but even then, like, dipoles go with one over distance power, so with far field. And your magnetic fields in the brain are nothing. So if you have a significant current going through those cables, anything, like what's going through a
There
laptop,
must be,
you're gonna feel it more strongly
there
than your
must be a
brain.
solution to that. This is working for 20 years.
And I'm very curious
I
when
don't know I feel embarrassed that I don't know the answer. That I always thought somehow to work it out, I will ask and email them.
yeah, or I'll just Google it, but it's very interesting.
We have a lot of cables here. In the
They are just hanging there.
Maybe.
So the closest one to our one is the one in Abu Dhabi. So, I used to go to Abu Dhabi to do stuff there, but now I don't. It's, they are as risky place as us.
And do you have opportunity to compare images